Hello dear student, I am Monroe Islam. Today in this video we are going to discuss some important question of CSIRNET, okay, of real analysis, and its chapter's name is sequence and series. Sequence of real number, okay, not series. So we will discuss day by day, okay. So this is first day of this chapter, okay. So I have taken 4 questions and we will solve this question in this lecture, in video, okay. After that we will solve another 4 or 6 questions in the next video, okay. And okay, you will hopefully if you understand my solution, okay. If you don't understand, you can always ask in the comment section, okay, and I will give you the brief discussion, okay, in the next video. So without delay, let's start. So let's start in this question, okay. So this question came in CSIRNET June 2018, okay. This is June 2018 question, and this is question of part B type. This is question of part B type, means 3 mark question, okay. And it is option 1 correct. Among them, option 1 will be correct. So you have to select the correct option now, correct one, okay. So see, it says that it has a problem in the question PDF, okay. I have taken the question from CSIRNET PDF. So don't worry, I am dictating the question. Xn is a conventional sequence. It's saying the Xn is a conventional sequence in R, and Y is a bounded sequence in R, okay. Then which of the following are correct? So first of all, we are going to eliminate the option, okay. Can you give me an example of conventional sequence? Simple example. I am taking Xn equal to 1 by n, okay. We all know this sequence converges to, if you take the limit, then Xn goes to 0. Is n to infinity, okay. So this is a convergent sequence. So this sequence is a convergent sequence, okay. Now if you take the sequence yn, this is -1 for n, okay, for some n belongs to natural number, here n belongs to natural number. Then this sequence is bounded, na. Then this sequence yn is obviously a bounded sequence because it is bounded by 1. As if you take mod of yn, then this is -n, this mod is 1, na. If it even, then it is 1. If it odd, then it is -1, always equal to 1. So it is bounded. You can say it is bounded also 2, okay, for n greater than 1. So it is a bounded sequence. So Xn is a conventional sequence and it is a bounded sequence, okay. Now if you take the sum, Xn plus yn, so take sum Xn plus yn, this sequence, okay. Xn will be 1 by n and yn will be -1 per n. Now can you tell me this sequence is convergent or this sequence is convergent? No, this sequence is not convergent, okay. Because this sequence is not convergent. Since this is not convergent, so their sum is not convergent, okay. Because if it convergent, then this should be convergent, na. But this is not convergent, so their sum never convergent, so it is not convergent, okay. So Xn is convergent, yn is bounded, it doesn't imply Xn is convergent, so option 1 is incorrect. Now it's saying Xn and yn has no common subsequence. No, it is false. See, also you can justify this because this sequence Xn plus yn, this has 2 subsequence, okay. This sequence has 2 subsequence because if you take the even part, if you take the even, means if you take the x to n plus y to n, okay. This sequence 2 subsequence, na. So this sequence is 2 subsequence, xn plus xn and x to n plus 1, y to n plus 1, okay. These are 2 subsequence of the sequence, this sum subsequence xn plus yn. This subsequence is nothing but 1 by 2n, 1 to n, and y to n means 1. And this sequence is nothing but 1 by 2n minus 1, so 2n plus 1, and this is, if you take the odd, then this is -1, okay. Now if you take the limit of this sequence, this goes to 0, so this goes to 1, so this goes to 1. If you take the limit, this goes to 0 and this goes to -1, so this goes to 1. So if this sequence is convergent, if you assume this is convergent, so there's all subsequence, this and this comes to the same limit, na. But this comes to 1, this comes to -1. How it convergent? So it is not convergent, okay. This sequence is not convergent. So it is not convergent, but it has a common subsequence because if you take the sequence x to n plus y to n, this sequence, this is subsequence of this sequence, na. X to n plus y to n, this is subsequence of the sequence xn plus yn, this converges to 1, okay. And this sequence x2n plus 1 y2n plus 1. This is also subsequence to sequence this sequence y xn plus yn. This also comes to minus 1. So it has two subsequence. This comes to two different limit. Okay. So how can we say that xn plus yn has no common subsequence? It has two common subsequence, na? So it is incorrect. 3 is incorrect. So xn plus y has no bounded subsequence. Now all if a sequence is convergent, it is bounded. Okay. Convergentness implies boundedness. If a sequence is convergent, see here. If a sequence there is a result, convergent implies boundedness. Okay, means if a sequence is convergent, then it is bounded. Okay, and proof is very trivial. Okay, you can easily prove. Suppose I am assuming xn based sequence, okay, of real number, obviously xn based sequence of real number. Okay, so I am assuming further it's convergent to L. So if it's convergent to L, so you can always tell mod xn minus L should be less than epsilon, na? For some epsilon, this is definition, and for n greater than some natural number n. Okay, now if you take the mod of xn, you can always write it like this: xn plus n plus L. Apply triangularity, so this gives mod xn minus L plus mod L. Okay, now this will be less than epsilon, so this can be made less than epsilon plus mod L. So you get a bound, take it m. So you get a bound na of xn for n greater than n. So you get a bound of n, so xn is bounded. Okay, convergence is boundedness, but reverse is not true. If a sequence is bounded, then it is not convergent, because it has an example. If you know the example, this sequence minus 2 n, okay, n greater than 1. This is a bounded sequence, okay, but it is not convergent, na? Because it has two subsequence. First sequence comes to 1, and it has on another sequence this comes to minus 1. Okay, minus 1 n. This two subsequence. Even this is the even one, minus 2 n. Okay, this comes to 1, and this is odd one, minus 2 n minus 1. Okay, this comes to minus 1. So convergent sequence implies bounded sequence. If a sequence convergent, it is bounded, but boundedness is not implies convergentness. Okay, it converges not true. So anyhow, so if a sequence, this sequence are convergent, x2n plus 1, y2n plus 1, both are convergent. So this is a bounded sequence, na? Obviously these are bounded because they are convergent. Convergence implies boundedness. This is also bounded. Okay, so it has two bounded subsequence, but it's saying the xn plus has no bounded subsequence, which is also incorrect. So correct one will be option 2. Okay, so in this question option 2 will be correct, but you can still in one statement you can verify this answer. Okay, no need to justify. I have just for your knowledge purpose I have given example and verify each option. Okay, so you can also tell like this: if x is the result, it says this what cut, huh? xn is convergent. Sorry, xn is, this sequence is bounded. Given, na? So I can say there is a real number m1 greater than 0, so that you can make mod xn should be less than m1 for all n greater than, you can say n1. Okay, now yn is convergent sequence. It is given that it is convergent. Now if I just tell that a convergent is equals boundedness, okay, so you can say from here that there is always m2, okay, greater 0, such that you can make mod yn should be less than equal to m2, na? For all n greater than n2. There is n1 is a natural number and n is another natural number. Now mod xn should be less than m1 for all n greater than n1, and mod yn should be less than m2 for all n greater than n1. Okay, now take, you can say suppose n1 is a, you can say suppose n1 here and n2 is here. Okay, so this result will hold for all n greater than n1, means after this natural number, and this result is hold for n greater than n2 after this natural number. So if you take maximum of these two, then this result, this also hold, na? So you have to take maximum. So take max n equal to, taking, if you take n equal to maximum of n1 n2. Okay, so for this n both they will hold, you can say mod xn less than m1 and mod xn less than m2, both are hold, na? For n greater than n. Okay, so now you can tell that mod xn plus yn, this should be less equal to mod xn, this should be less equal to mod yn. Now mod xn is less than m1, this is less than m2, so this is less than m1 plus m2 for n greater than m1. From this you get a bound, na? Xn plus 1 subsequence, for subsequence xn plus 1 you get a bound. So from here you can say this sequence xn plus 1 is a bounded sequence. Okay, from here you can say this is a bounded sequence. So your answer is correct. Okay, so option 2 will be correct in the question. Hope you understand my solution. Okay, if you have any doubt, you can always ask in the comment section. Okay, so we are going to yeah, one more question. This question also asked in June 2018. Okay, June 2018 is all part of question. It's saying a1 is 1 is it giving a recurrence lesson and an plus 1 defined by this. Okay, so you have to find this limit supreme n, limit infimum n, and supreme infimum n. Okay, so without just type for shortcut being I'm giving you trick. Okay, don't think this question too much. Okay, just take limit. Just take limit on both sides. If you take limit in both sides, then I'm assuming that n tends to l. Okay, and if it n tends to l, then we all if a sequence corresponds to some limit is n tends to infinity, and it every subsequence corresponds to same limit. So you can say n plus is subsequence of n, na? So this goes to also l. Okay, now if you take a limit in both sides, so you get l here. No matter half mass run. If we get half, mod n tends to l, and this is to l plus 1 by l. Okay, so you get l is 2l square. Okay, that is l square plus 2, I think. Okay, so from here you get l square minus l square is l square, na? So l square is 2, so this is l equal to plus minus root 2. Now it is saying if first term a1, the sequence first term a1 is equal to 0. How can we l equal to minus root 2? Because first term is equal to 0, na? This is negative, so this is not possible. So what is the possibility to be l? L will be root 2. Okay, so for the sequence limit is exists, na? For the sequence l limit, I am assuming limit n equal to l equal to root 2. So this will be limit supreme n. So limit supreme n will be root 2. Okay, so this is option also not be correct. Okay, so we understand my solution. Now we are going toward the part C type question. Okay, this is all part B type question. Now we are going to solve part C type question. This. Okay. Okay. So now we are going to solve some part C question. Okay, this question from part C 64, and this question is also from part C June 2017 question. Okay, so discuss this question. We will discuss this question first. Okay, so where is the pen? See, this question asked in June 2017. Okay, this is part C type question. Okay, means it is MSQ type question, more than one right. It's saying AB is some natural number, AB belongs to natural number such that Dn is a sequence defined by this n greater than AB. Then as n tends to infinity, which of the following is not true? There are 4 options are given. Okay, so I'm going to check it one by one. So you have to, for better understand, fix some values of A and B. This A, B are natural number, so you can choose A, B, any arbitrary natural number. So for my convenience, I'm choosing AH1 and B is 2. I'm choosing this, okay, without loss of generality. For my sake of convenience, okay, I'm choosing A equal to 1, B equal to 2. So for this natural number, I can say H less than B, na? H less than B. I'm choosing like this. So if you can see option says Dn is convergent for loss AB, A less than B, A equal to B, A greater than B. So I am assuming this case A less than B. In this case I am doing, okay. So in this case so I am doing option 2. So according to this, Dn equal to what will Dn? A means 1 and bn begins to, so it will be nc1. nc1, how we break this? N factorial, n minus 1 factorial, and 1 factorial, na. nc2 means the upper side, so it will be n minus 2 factorial, 2 factorial, and it is n factorial. Okay, so n factorial, you can cut it. So this gives n minus 2 factorial. 2 factorial means 2 into 1. Now it is n minus 1 means n minus 1 into n minus 2 factorial, right? So if you cut this, so it gives 2 by n minus 1, I think. 2 by n minus 1. Okay, so if you apply n to infinity, so this gives this 0, na. If we take limit n to infinity, so this gives n to infinity, something will be 0. So this is 0. So dn is a constant sequence. So option 2 will be correct. So option 2 will be correct. Now, but if you do the reverse, a greater than b. For a greater than b, choose a equal to 2, b equal to 1. Okay, for a greater than b, for option 4, choose a equal to 2 and b equal to 1. Then a is greater than b and a be a natural number. Okay, now calculate dn. dn equal to nca means nc2 and nc1. Okay, so this gives n factorial, n minus 2 factorial, 2 factorial. This gives n minus 1 factorial, 1 factorial, and n factorial lower side. Because it is lower side, na, so it will be reverse. So n factorial. So this gives n minus 1 factorial, means n minus 1 into n minus 2 factorial. This is n minus 2 factorial, 2 factorial, 2 into 1. So this will be n minus 1 upon 2. Okay, so dn will be, so here if you get dn equal to n minus 1 upon 2. So if you take a limit at this infinity, this goes to infinity, na. So how it converges? So it is a divergent sequence. So if a greater than b, this is a divergent sequence, not convergent. So for option 4 is incorrect. Okay, now a equal to b, you no need to check. If you made a equal to b, what happen? If you take a equal to b, means a and b both equal. So take a equal to b, so this is 1 1. So dn equal to 1. So dn is 1 for any initial element, na. So then in this case dn belongs to 1. Okay, if you a equal to b, so no need to calculate. So option 3 is correct. So dn belongs to 1 if a equal to b. So option 2 is correct, option 3 is correct, option 4 is correct. Now it says dn belongs to 4 plus ab. No, if you take a greater than b, if you take a equal to 2 and b is 1, for this case it doesn't belong, na. So it's incorrect. So hope you understand. Are you got one point? If you need out, you can always ask in the comment section. Okay, so option 2 and 3 correct. So in this question, correct option will be option 2 and option 3. Okay. Okay. Now going to one more question. Okay. This question asks. Sorry, I have told you wrong. This question asks in June 2017. June 2017. Yeah. This question asks in June 2018. This question asks in June 2018. Okay, CSIRNET. This is also part-1 question. Means it is more than one option correct. Okay. So A and B and C and 2 are 3 sequence. They are giving the 4th option, which is the following is not true. Okay. So for this you have to know what does mean sufficiently large plus n. See, in all options is given sufficiently large plus n, sufficiently large plus n, sufficiently large plus n means nothing but n can be made however large. It means n can be 10 to infinity. Okay. This is if n tends to infinity, then n greater than cn. N sufficiently large means n can be sufficiently large. N can be tends to infinity. Okay. Or you can say n is sufficiently large. You can make n greater than however large number g. This is however large. You can have thought however large number g. Your n can be made however large number greater than g. However large number g. Okay. This is the meaning of sufficiently large. So a and b and c n. There no doesn't matter what is the sequence. The constant. Okay. The constant is no meaning. Okay. If you try to find limit without the constant, then it is also fine. Okay. So I am doing that. Without constant, because constant no what na. If it tends to infinity, then it's constant to infinity is also infinity. So I am doing my calculation with the constant. So it's say n greater than cn for the sufficient limit when. Okay. So I am first calculating this. What is n upon cn? Calculate this. Calculate this limit. Okay. If n is 2 by n and cn is what is cn? N square. Okay. Now if you take limit n to infinity, limit n tends to infinity. So limit n tends to infinity. So this will be infinity, this will be infinity. So I will be infinity part. So to apply L square rule, ln to n and this will be 2n. Now this also tends to infinity, this also tends to infinity. So you take limit, this is infinity. Okay, there is no place here. See, I'm doing below. First option, what is n? I'm calculating my n upon cn. Okay, so this is nothing but 2 and I'm is calculating limit. So limit n upon cn 2 n, and this is n square, I think. Now it tends to infinity, it tends to infinity, s tends to infinity. So you can make this limit tends to infinity. Take, you have to divide this part is infinity, this is infinity, so you can apply LHospital rule, na? So I am applying LHospital rule. Yeah, so if you apply LHospital rule, you have 2 to n log 2. Okay, so this goes to n. Now it is also tends to infinity as n tends to infinity, because this tends to infinity and this also tends to infinity. So both upper part and lower part both tend to infinity. So you have to, you can always apply LHospital rule, na? So you can apply. So you got 2 to n ln 2 again, so ln 2 square, this is 2. Now it this tends to infinity and this is constant, na? So total tends to infinity, so this limit will be infinity. So limit, you can say limit n by cn is infinity. Okay, from here you can say limit n this is infinity, n by cn, this is infinity. Okay, now definition of infinite limit. What is the definition of infinite limit? Apply the definition of infinite limit. You can say this limit is infinite. What does meaning? It meaning n by cn can be met however large number greater than g. This is however large. However large. Okay, so it will however large, na? So it will can be greater than 1. You can always say for all n greater than for n for n, or you can say for all sufficiently large n. Okay, so you can say n by cn greater than g, however large number, and since however large number, so it must be greater than 1, na? It is however large, so it is obviously greater than 1. So from here you can say n will be greater than your cn. Okay, for sufficiently large n. Okay, so this option is correct, na? Option 1 is correct. So you can say option 1 is correct. Now going to option 2, bn greater than cn is sufficiently large. Bn greater than cn for sufficiently large means bn by cn limit into infinity gives infinite. Okay, so check whether it is giving infinite. If you do bn by upon cn, I am doing here. Okay, if you do bn upon cn, bn take limit n tends to infinity. Okay, so limit n tends to infinity. Bn means is log n and cn means is n square. Okay, so now take limit n tends to infinity, this is infinity. So it will be, if we apply LHospital is 1 by n, this is 2n. Now if you take limit, this is 0, na? This is 0. So bn by cn limit is not infinity. So see, it is not infinity, so you can not say that bn greater than cn by applying the definition. Okay, because this limit n tends for large values of n is bn upon cn limit 0. So it is, how can we say that bn upon cn is greater than how large number? Okay, because it is for large values of n, because if it is large values greater than for large values of n, na, then you can say bn greater than cn for something large values of n, because it limit n is infinity 0, na? So you can never say. Okay, because since the limit 0, so applying the definition of limit, you will get this bn bn upon cn minus 0, this should be less than epsilon. So we get bn should be less than epsilon cn. Okay, so we get reverse similarity, not between the cn. Okay, so from here you can say this is not correct. Okay, similarly if you bn greater than for something large version, so for this if you do try to find the limit of bn by n. Okay, see if you find the limit bn by n, option 2. Option 2 says that this bn greater than n for sufficiently large values of n, na? This means nothing but this bn can by n greater than 1 for sufficiently large values of n. Okay, okay, so you have to calculate bn upon n. Okay, bn upon, what is bn? Bn is nothing but, see here bn is nothing but log n. Okay, bn is log n na, so bn is log n, it is n. Now compute limit n tends to infinity. So if you compute limit n tends to infinity, so this is infinity. So if log n infinity is 1 by n, applied as per rule, this is 1. Limit n tends to infinity, this is 0. So this limit is 0. How can I say it bn upon n, b1 upon n, here bn upon n, this limit n tends to infinity is 0. So you can say this bn minus n is 0, so it will be less than epsilon. Okay, this can you say for all sufficiently large n. Okay, from here you can say bn mod of bn will be less than epsilon n. Okay, for sufficiently large n. So from here you never get bn greater than cn. Okay, you get mod bn less than epsilon cn. So for this na, if bn greater than n for sufficiently large n, you get the limit infinite. Bn n for sufficiently large n, you have to get this limit is infinite. Okay, then it is also possible. Then it's possible. But you get limit 0 na, so how it is possible? It is not possible. Okay, so it is incorrect. So option 3 is incorrect. Okay, now an greater than bn for sufficiently large n. Okay, so try to find the limit of n upon bn. N upon bn. Actually, I've done n greater than cn na for sufficiently large n. I've done 2 to the power n upon n square. Actually, that was actually option 2 to the power n upon n square. This was option actually D. Sorry, this is for option D. Okay, not option 1. Option 4. Because if n is 2 to the power n and cn is not cn is this is for option D. Okay, but for option D is correct. Okay, because if you convert the n by cn, the 2 to the power n by n square, this gives limit infinite. So you can say for n greater than n by cn can be made greater than half less than g. This half less than must be greater than 1. So you can say a greater than cn for sufficiently large n. Okay, cn for sufficiently large n. You can say this for option D. Okay, so I have not done option A. Now I am doing option A. Sorry. So I am to option A. N greater than cn. Okay. Now n greater than bn. Okay. N this will be correct. This is incorrect. This is incorrect. Now n greater than bn for sufficiently large n. Okay. For this you have to find n by bn limit. Limit n infinity n by bn. If you limit infinite, then it is true. If it is not infinite, then it is not true. Okay. So try to find the limit n upon bn. What is the limit n upon bn? Okay, try to find the limit. For option D, try to find limit n to infinity n upon bn. Okay. Now, if you compute this limit n to infinity n will be nothing. It is 2 by n, I think, and this is log n. Okay. I am erasing the constant because constant what no matter. What may be the constant? It is not matter. Okay. To do much solution. It's constant na. So what it defect with limit. Okay. Constant never differ limit. Okay, constant never gives any effect in calculation in this conclusion. Okay, so no to worry, don't worry. So n by n is 2 to n and bn is log n. So n upon bn, what will be n upon bn? 2 to n upon log n, 2 to n upon log n. Now if n is infinite, this goes to infinite, this goes also infinite. Now limit n is infinite, this will be 2 to n log 2 na. If we apply L-square rule, so this is 1 upon n. Okay, by applying L-square rule. Okay, because it is infinite, n is infinite, so you can derive upper and lower part also. Now this gives limit n to infinity n to the n log 2. Okay, so if you take infinity, this is limit infinite na, so this infinite. So since this limit infinite, so you can say n by bn greater than how large number g. Okay, so from this you can say limit n to infinity n upon bn, this limit infinite. So that means this can be made how large number greater than g. This can be made how large number greater than g. And how large? So this must be greater than 1. Okay, for all sufficiently large values of n. So you can say n greater than bn for sufficiently large values of n. Okay, so this option is correct. So this is option D. So option D is correct. So in this question, option A and D are correct. Okay. In question, option A and D are correct. So if you understand my solution, if you are in doubt, you can always ask in the comment section. Okay. So in this question, option 1 and 4 are correct. Okay. So if you are in doubt, you can always ask in the comment section. In the next video, I will take another 4 or 5 or 6 questions maybe whatever be possible question, I will discuss that. Okay, so if you need out, you can ask in the comment section, and I'll upload this PDF in the description. Okay, you try to find, first of all try to solve this question by own. If you don't getting this solution, okay, then you see my video. Okay, and if you get it out, you can always ask in the comment section. Okay, so today video you have to solve this question from part C, and okay, and this question from part B, this question from part B, and this from part C. Means two parts question, two part B question. Okay, so how people will solve, how much marks? Part B question carries 3 marks. You all know. So we solve 3 question. So this brings 6 marks, and we will solve get 4% right from 2 part C question. So you can get 8 point something. So if you solve, get, so you can say 50, approximately 50. Okay, so in this video we will solve 50 type, approximately 50 mark question. Okay, in the upcoming video we will also discuss so many questions, so don't worry, follow my channel and subscribe my channel. Okay, you will get everything here. Okay, so without delay, so try and solve more questions. Okay, so thank you.